We're going to start with a line graph already set up. So the first thing that we need to do is grab bar from VX shape, and this will allow us to render a transparent bar over the entire SVG. If we attached our data listeners for mouse moves on top of our line path, it would be a very constricted space that we could then hover over. If we render an invisible bar over everything, then anywhere we move our mouse, we can actually get the mouse coordinates. So we're going to set up the exact same coordinates that will just cover everything we have here. So x equals 0, y equals 0, the width, the height. We're going to fill with transparent. We're going to pass in Rx equals 14. So we're basically just duplicating what our rectangle is, which is the visible portion. And then we'll pass in our data, which is just stock. And then we'll attach our on mouse move. Now, VX will call any functions that it detects and inject the data that it has. So if this is some sort of abstraction, you don't have access to the original data, this is what it will pass to it. So we're going to say data, and then event, and then we're going to say call a function. For us, we'll just call this .handleDrag, which we have not created yet. And we'll pass in our events, we'll pass in our data, we'll pass in our X selector, we'll pass in our Y scale, and we'll pass in our X scale. Now, the reason that we are doing this is just because our function will then receive all of the data and all of the functions that it needs to figure out where exactly our mouse is and how we need to render things. So now let's go create our handle drag. So we'll create a handle drag, and we will then destructure our event, our data, our X selector, our X scale, and then our Y scale. The goal of this function is to take an event, figure out where it's at, and then convert that into an index of existing data. So we're going to first say const x, and we're going to destructure and call local point from our event. This is from VX, and it's going to figure out a relative point to the SVG. Otherwise, it would be relative to the actual document, and we don't want that. And then we're going to say const x0 is equal to x scale dot invert, which will then take a point and invert it into a data point. So this takes a coordinate and turns it into x0, which, because it's a scale time, will actually just be a date instance. So then we're going to say let index equal bisect date, pass in our data, our x0, and a minimum value of 1. And what this is going to do is take all of our data and the data point that we're looking for and find the closest value that it can to that. This is usually used for data insertion, but it can also be used to find the closest point. And this bisect date comes from our bisector, which we've passed our X selector and then said we want the left side. This could also be the right side. So if it leaned either way, it would point to either left or right, and we've just arbitrarily chosen left. So now, because we've set our minimum at 1, we're going to get our two data points. So const d0 is equal to our data, which is our index minus 1. And then d1 will be data index. So now we're going to say let d equal d0. And then we're going to check if we even have a data point at the current index that we're at. So if we have d1 and we have a date, then let's do something. So in our case, we're going to compare the x0 to the date and see which one's closer. So if x0 minus the X selector with our d0 data point is greater than X selector d1 minus x0, then this is basically going to say that we are closer to the data point 1, and that way we want to set our data point to d1. Else, we're going to say our data point is still d0, and then we'll do index equals index minus 1. So that way we set up our data point and then the correct index that we are going to use. So now with that all set up, we're going to do a this.setState, and we're going to set our position with our index that we've picked, as well as our x position. Now we could theoretically derive this in the render function, but I'm just going to set it here for simplicity's sake. So we're going to have to use our x scale, and then we're going to take our x selector and pass in our data point. So this will select the date and then scale it to the actual coordinate of where exactly our mouse is moving and the closest data point. So now we can just destructure from this.state what our position is, and then we can render a line. So here, if we have position, then we can render a line, and this line is from VX, but it basically is a helper method to just draw a line. And we'll do our from, and our from will be an x and y, which will be x position dot x that we've figured out, and then y will just be the top of the graph. And then if you say 2, it'll just still be the position x because we're drawing a straight line down, and then we'll say it is the bottom of the graph. And we'll give it a stroke width of 1. So now if we go and take a look, we can see that when we move our line or our mouse across the screen, that we render a line. However, when we move away and out of it, it doesn't disappear. So let's fix that. So we need to adjust, instead of just an on mouse move, we need to add on mouse leave, which with VX it'll get called with our data, then eventually our event, and then we'll just say this.setState and clear out our position and set it to null. So now that we have the bar showing and hiding, we need to actually render our second line. So we're going to take our line path and just duplicate it. Let's say position and our line path. And with our line path, we don't need to adjust any of the scales because they're already set up perfectly to take our current data set and render a line and scale our data up correctly. So all we need to do is adjust our data. So with this, we can do .slice, type position.index, which will take our index all the way to the end of the array. So we also then need to adjust our coloring. So we'll say stroke equals RGBA, 255, 255, 255, and 0.5. This color can be anything, but it's just a opaque white line. So now here, we can now see that we are rendering a line and then also rendering a second line. However, it is right over the top of our other line, and we want it to render as a separate line. So to fix this, we need to adjust the data of our normal line. So we'll say if we have a position, then we'll do stock.slice from 0 to our position.index. Otherwise, if we don't have a position, we'll just render the full stock line. So we're not messing with any scales, we're just adjusting our data when we need to. So now we can see here, we're rendering a opaque white line and then adjusting our other line to render right up to it.